Hey everyone, in today's lesson, we're going to see how market equilibrium is determined. We'll learn how to find the equilibrium price and quantity graphically and mathematically. Let's get started. We've already seen in previous videos that the demand curve and the supply curve show how buyers and sellers behave in response to changes in the price of a good. Today, we're going to explore how their interactions set the price that balances the market, also known as the equilibrium price. Graphically, market equilibrium occurs where the demand curve and the supply curve intersect. This is the equilibrium point, right here on the graph. We represent the equilibrium price as P star. At the equilibrium price, the quantity demanded and the quantity supplied are equal and is represented by Q star. At the equilibrium price, buyers purchase everything they want to buy, and sellers sell everything they want to sell. At any other price, forces come into play that push it toward the equilibrium price. We'll talk more about these forces in an upcoming video. Now that we've learned how to determine the equilibrium price and quantity graphically, let's see how to calculate them mathematically. Consider the following demand and supply functions for a given goods supply. P equals 100 plus 0.2 Q. Demand, P equals 150 minus 0.3 Q. First, let's look at the supply function. Even if it wasn't labeled as supply, we could easily identify it because of this positive sign right here. The positive slope means there's a positive relationship between price and quantity, just like the law of supply states. Now, the second function is labeled as demand. This negative sign here indicates the inverse relationship between price and quantity, exactly as described by the law of demand. So, how do we find the equilibrium price and quantity? To do that, let's remember what we saw in the previous slide. At equilibrium, the quantity demanded is equal to the quantity supplied, and the price is the same for sellers and buyers. So, to find the market equilibrium, we simply set the two equations equal to each other. P equals P. That gives us 100 plus 0.2 Q equals 150 minus 0.3 Q. Now we can replace both Q by Q star, the equilibrium quantity. Now let's solve for Q star. First, we move everything with Q star to one side and the constants to the other side. When we move minus 0.3 Q star to the left side, we invert the operation. It is subtracting, and we change for adding it, plus 0.3 Q star. And we move 100 to the right side, inverting the operation. It is adding, and we change for subtracting. Minus 100. 0.2 Q star plus 0.3 Q star equals 0.5 Q star, and 150 minus 100 is 50. 0.5 Q star is equal to 50. To isolate Q star, we need to move 0.5 to the right side, since it is multiplying Q star and we pass to the right dividing 50. Q star is equal to 50 divided by 0.5. 50 divided by 0.5 is 100. Then Q star is equal to 100. This is the equilibrium quantity. Now that we know the equilibrium quantity, let's find the equilibrium price. To do that, we simply substitute Q star equal to 100 into either the demand or supply function. It doesn't matter which one. Let's use the supply function. P equal to 100 plus 0.2 times 100. That simplifies to 0.2 times 100 is 20. 100 plus 20 is 120. So the equilibrium price is 120. Now let's do one more exercise. If you're enjoying this content, don't forget to subscribe to our channel to help us grow. Refer to example 2.5, page 59, on the market for wheat. In 1998, the total demand for U.S. wheat was QD equals 3,244 minus 283 P, and the domestic supply was QS equals 1,944 plus 207 P. At the end of 1998, both Brazil and Indonesia opened their wheat markets to U.S. farmers. Suppose that these new markets add 200 million bushels to U.S. wheat demand. What will be the free market price of wheat, and what quantity will be produced and sold by U.S. farmers? In sum, the problem is asking us to calculate the equilibrium price and quantity considering a new demand. In 1998, the demand for U.S. wheat was QD equal to 3,244 minus 283p. And now new markets added 200 million bushels to U.S. wheat demand. So the new demand for U.S. wheat is equal to QD plus 200. Let's substitute QD by the expression 3,244 minus 283p plus 200. QD new equal to 3,244 plus 200 is equal to 3,444 minus 283p. Now we use this new demand function and the supply function to calculate the new equilibrium. To do that, we need to remember that in equilibrium, the quantity demanded is equal to the quantity supplied. So QD new is equal to QS. So we set the equations equal to each other. 3,444 minus 283p equals 1,944 plus 207p. Now we can replace both p by p star, the equilibrium price. And we solve for p star. We move everything with p star to the right side and everything else to the left side. We move 1944 to the left and invert the operation. It was being added, now it's subtracted. We pass as minus 1944. Minus 283p star is subtracting, and we pass to the right adding plus 283p star. 3,444 minus 1944 is equal to 1,500, and 207p star plus 283p star is equal to 490p star. Now I'll just flip them around. 490p star equal to 1,500. Doesn't change a thing. Now to isolate p we need to pass 490 to the right side. 490 is multiplying, then we pass dividing. So we have p equal to 1,500 divided by 490. P is approximately equal to $3.06 per bushel. Now we need to determine equilibrium quantity. To do that, we substitute 3.06, the equilibrium price, into either the demand or supply function. It doesn't matter which one. Let's use the demand this time. QD, new equals 3,444 minus 283p, substituting 3.06 into p. QD new equal to 3,444 minus 283 times 3.06. QD new is equal to 2,578.02. That's all for today. If you enjoyed this video, don't forget to leave your like and subscribe to the channel. Don't forget to activate the bell to be notified when new videos are posted.